And question 2 is about investigating forces by stretching a spring. And this is Hooke's law. So the first bit is suggest 2 ways that the student can measure distance h more accurately. So if you look at the mark scheme here, you've got 6 options here. You had to get 2 of them. The first one is the mention of no zero error. Now, zero error here is if the end of the ruler is not measuring from 0 or it has been worn away and is no longer true 0. The second one is the fact that the ruler should be vertical, 90 degrees or perpendicular was acceptable here. The use of a marker such as a pin to line up the base of the masses with the scale. The use of a ruler with finer calibrations or smaller intervals or smaller divisions was acceptable. A means to reduce parallax error. Now this is by getting your eye level when reading the scale, and the use of a caliper. You weren't allowed a more accurate ruler, but a caliper is a special measuring instrument which is more precise. It can measure down to 0.1 millimeter very easily. Okay, the next part was all about independent and dependent variables. Now, this was, I think, something which people weren't remembering. So here, your dependent variable is what you measure. Your independent variable is what you change, and in this case, that was the mass. That's what you changed in the experiment. And you converted that to force. This is in the second part of the question here, but what you measured was the distance in centimeters. So the dependent variable is the distance. And here, explaining how the force values were calculated, showing you the mark scheme here again. This is the idea that you're using weight equals mass times gravitational field strength. So you could have had this in any form. The second marking point was changing your grams to kilograms. And the third one was the idea that for 1 Newton for every 100 grams. And the last point, which I think was, it comes under the category of state the obvious. G is 10 newtons per kilogram. Or the idea that this gravitational field strength times 10 would have also got you a mark here in part B. Now, the next part of the question is drawing the graph, and I always find this incredibly tricky with screencasts. So I will show you an effort that I prepared earlier. It's not the most perfect graph, and if I drew a graph like this on a piece of paper, I would be scrawling neater and things like that to you. So the idea is here that in a graph you need to use the full graph paper by choosing the correct scales. Now, some of you were using 3 squares for 1 centimetre. Now this is what we call awkward scales, and it makes it really difficult to plot accurately. So the first mark was for choosing and numbering your scales correctly. If you put your masses down here instead of forces, you lost this mark. Now, the next mark was for putting your quantities and your units. And I'm glad to say I didn't often penalise people for forgetting units, so thank you very much for remembering units. There was 2 marks available for correctly plotting your crosses. So here we've got 0.2 was 4.6 centimetres, 0.4 was 3.9, and so on. And you can see this is an unusual graph, and this all goes back to the fact that we're not plotting extension here, so we're not going to get a traditional graph which is directly proportional starting at 0 and going this way. Right, so the next thing you need to add is a line of best fit. This needs to be drawn with a ruler, and it needs to be a straight continuous line. So I'm going to put on a straight line, and I'll do that next. Right, I've now drawn in my line of best fit, and now you can see why I put crosses on please use crosses, because these papers are scanned and sent to examiners around the world. So if you put a little dot, it can get lost behind your line of best fit, and it doesn't show clearly where you plotted your points. And as there's 2 marks available for that, plotting the points, I think it's wise to be safe and use clear crosses which show up. Now, the second part now asks you to use your graph to find the force for which H is 0. So what you need to do, and I did this in one fell swoop, is extend your line past so it hits the forces axis here. And the mark scheme said that you actually had to give your answer to 3 significant figures. So here on my graph, this is 1.42 newtons, 1.42 newtons. Now, on my graph it's 1.42, but anything between 1.40 to 1.46 newtons was the acceptable range for this particular graph. Now, I think this was quite a tricky question. Explain whether the spring obeys Hooke's law. Now, Hooke's law is the fact that force is directly proportional to extension. And here, this graph is not directly proportional because it's not a straight line going through 0. However, it is a straight line. So I'll show you the mark scheme and you can see where you would score marks here. So if you just put no or yes, you didn't get a mark. You needed to give an explanation. So if you had put yes, the correct statement of Hooke's law, which was extension, is proportional to force. Yes, if you put directly, we would ignore it, but that would have got you 1 mark. And you could actually say, show it as proportional because there's an equal step down for the distance with the force. So I bombed out on saying that correctly. And the line is straight. Now, you weren't going to go graph is directly proportional. That's wrong. Inversely proportional. No, they weren't looking at that. It was the idea that you've got equal steps for distance as you increase the force. Also, the line goes down because here it goes back to this idea that different distance has been measured. But the extension can still be worked out, or you've got this idea that more force is a larger extension. And no, it doesn't obey Hooke's law. The graph does not pass through the origin. So those were any of those 2 marking points were gained your marks here. As I say, I think this was the trickiest bit of this question. Right, that's the end of the question, and there was 14 marks.